Hi everyone, my name is Shiya. I'm a computational biologist. I previously worked at Ancestry and now I work at Amgen. Um, my mentees, as you see, she's Mira and she's 15, a 10th grader. And we've been working together on a study regarding inbreeding in dogs and health implications associated with inbreeding. Um, Mira loves animals, especially dogs, and she also likes math. So this is a good combination of things she's really excited about. This is both me and her first time in this program, and so it's a great learning experience for both of us. And here she will present this study to you.
So Shia just introduced herself. So my project is dog breeding and its health effects. The picture on the right is of my dog, Leo. So that's kind of why I selected this project. I really like dogs, and I've also always liked biology, but I've never really studied it. So through the project, I've learned genetics and molecular biology. I also learned how to use genetic databases and learned how to use Microsoft Excel and did data exploration through that. In the future for this project, I would go in depth with more breeds than I did to get a more comprehensive understanding. So like I said earlier, I never had really studied biology. So it was both difficult to have a biology project, but it was also kind of fun because I've always wanted to learn about it. And then as the shelter in place started, it became more difficult to meet and kind of work together because we couldn't sit side by side. But we managed, and I thought it was all around a really valuable experience because I got to work with someone who's so experienced and learn about something that I've been interested in so long. Okay. So what is inbreeding? Inbreeding is a result of offspring from breeding closely related parents genetically. Inbreeding can enhance specific traits and characteristics, but also increases the possibility of gaining genetic-based diseases. Inbreeding is measured by something called the inbreeding coefficient, which assesses the extent to which an offspring's gene pair is present in both the mother and father. And as you can see on the chart on the right, if the inbreeding coefficient is 0, it shows no relation between the parents. A 12.5% inbreeding coefficient shows half sibling relationship. A 25% inbreeding coefficient shows either full sibling relation or father-daughter relation. And a 3.1% inbreeding coefficient shows half cousins. The higher the inbreeding coefficient, the higher a likelihood of the offspring will inherit a genetic disease. And inbreeding coefficients are calculated in 2 ways. You can either calculate it from genotype data or from pedigree information. So inbreeding coefficient from genotype data. To find the inbreeding coefficient from genotype data, you need to determine what is called heterozygotes. A heterozygote is an organism that carries 2 non-identical alleles for a specific trait. All animals have 2 alleles at a gene. After that, then there's a formula to find the coefficient, which is 1 minus the observed heterozygotes divided by the expected heterozygotes. To find the observed heterozygotes, you can observe the organism's genetics and observe whether the organism's allele is composed of both a dominant and recessive gene. If an organism has both dominant genes, it's called homozygous a major allele, and if they're both recessive, it's called a homozygous minor allele. And then both heterozygous, it's called heterozygous allele. To find the number of expected heterozygotes, you need to find the frequency of the dominant and recessive alleles at a gene. To find the frequency of the dominant allele, you take the probability of an offspring getting a homozygous major allele and add that to half the probability of the offspring getting a heterozygous allele. To find the recessive allele, you follow the same process, but with the probability of a homozygous minor allele instead. Then you multiply the frequency of each by 2 and the total number of alleles in the organism to find the expected number of heterozygotes. And then you can just plug all the values into the equation to find the inbreeding coefficient. If an organism has a homozygous minor allele or 2 recessive genes, it's most likely to have the disease because diseases are recessive mutations. For example, looking at the table on the right, if this specific organism had both lowercase w's at alleles at a gene, they would inherit the disease. Inbreeding coefficient from pedigree information. To find the inbreeding coefficient from pedigree information, you need to be able to see the family's full pedigree chart, and I attached, I guess you'd say, Zulu's pedigree chart on the bottom. Zulu's parents share an ancestor 2 generations prior through Ajax, so Zulu is inbred. To find the inbreeding coefficient, there's a formula. It's 1/2 to raise to how many ancestors are in the breeding loop. For Zulu, it would be 1/2 to the 5th power because Carl, Eva, Boris, Deb, and Ajax are in her breeding loop. This is a coefficient of 1/32 or 3.1%, which is grandfather-granddaughter relation. Breeders often use pedigree information to find the inbreeding coefficient because it's easily accessible, especially to breeders. The graph on the bottom right shows that the average inbreeding coefficient in golden retrievers can be as high as 25%. Right, so why do dog breeders inbreed? Dog breeders inbreed because it allows for them to produce dogs with very predictable traits and desirable traits. These desirable traits attract buyers, and often inbreeding is used to produce dogs like show dogs. Genetic mutation that is caused by inbreeding is very often the desirable trait buyers want. So for example, the picture on the bottom is of a Shar-Pei, the breed is known for having wrinkled skin and coats, and that's actually a mutation caused by inbreeding. But breeders noticed that that was a mutation that buyers liked and they wanted in a dog, so they continue to breed Shar-Peis. The health effects of dog inbreeding. Inbreeding causes many dangerous health effects. Some of the prominent ones are inbreeding depression, which means a reduced litter size, greater puppy mortality, a reduced lifespan for the puppies, and reduced fertility of the puppies. Some health effects are behavioral, like serious aggression that can never be trained to decrease, and also a general decrease in the dog's genetic pool, which leads to a higher chance of passing on medical conditions to their offspring. At the right bottom is a English Bulldog, which is a breed that has been so inbred that the health effects the inbreeding has caused on the breed, which includes high risk of skin infection, difficulty to breathe because of really narrow nostrils, and deformed spinal bones can never be solved. For my research, I pulled data from a research article that studied 152 diseases in over 100,000 dogs. Okay, I have pasted 2 images from the Excel sheet in the article below. In the Excel sheet, each row represented a dog breed and each column represented a disease. Using the Excel sheet, I calculated the alleles present in each disease, the frequency of each, and the inbreeding coefficient, which is shown on the right. It's just shown for 3 random diseases. And for each disease, A1 represents a reference allele and A2 represents a disease allele. And as you can see from the little bit of data that I pulled, there are many more reference alleles than disease alleles in all diseases. Okay, so specifically, I examined 2 diseases in the Excel sheet within 2 breeds: golden retriever ichthyosis in golden retrievers and degenerative myelopathy in Akitas. The 2 screenshots above the chart are from my Excel sheet calculations that shows their inbreeding coefficient for the diseases, and the bottom row on the chart shows the inbreeding coefficient. I also calculated the frequency of the disease allele, which indicates how likely a dog is to receive the medical condition. So for example, among the 100,000 dogs, 9.7% of Akitas have the disease allele A2. Although these diseases are most prevalent in golden retrievers and Akitas, the frequency of the disease allele in all purebred dogs is very high as well. So in the last column, you can see that the frequency of disease allele among all purebred dogs is 5.4% for degenerative myelopathy. As seen on the previous slide, the inbreeding coefficient for the disease in golden retrievers is 25%, which is really high, as is the frequency for the disease allele. Inbreeding is causing this disease allele to become more and more prevalent, especially in golden retrievers. This mutation is recessive mutation, which means that both parents will need to carry the defective gene, which in the chart below is shown by the gene ICH, in order for the offspring to receive it. But as you can see in the second row in the chart, even if only one parent carries the gene, the offspring may receive the defective gene, which shows the danger of inbreeding because it greatly increases the risk of the diseases. The gene that causes this disease was first found in golden retrievers, but after a lot of research and testing, it was then found that humans have a similar gene, which leads to the disease autosomal recessive congenital ichthyosis in humans. Researchers often find the disease gene in dogs to find human disorders, which shows how closely related we are, and it helps humans understand our own genetics. And for this disease, well, the disease is a skin disease that results in dark, thick skin that is very flaky. The disease in dogs is, the gene name is PNPLA1, and it is caused by shortened proteins. Okay, so action against inbreeding. Dog breeding is not yet illegal, just as human inbreeding is. But there's lots of development within genetic testing for dogs to combat this, and breeders can test their dogs before breeding them to assess the risk for certain diseases. Dog owners can also test their own dogs to see if their dog is a disease carrier in order to take precautionary measures. Additionally, many organizations such as the Assured Breeders Scheme are working to promote good breeding practices and to stop puppy mills and irresponsible breeders who use inbreeding to increase profit. To help combat this issue, you can do research on your breeder before you buy or adopt from a shelter. So as I mentioned earlier, I love dogs, so issues like these are very important to me, but others who do not feel the same might ask, why should I care about their health? Dogs are domesticated from wolves, so therefore a lot of the traits dogs have are domesticated traits, like their fluffy ears, and behavioral traits, like their attachment to humans. We need to learn to aid these animals because they're literally called man's best friend, and they can do so much for us. And as shown earlier through the ichthyosis example, we were able to identify a human disease through dogs. So dog genetics are pretty similar to our own, and they can help us understand and combat human genetic problems. Thank you.